All right, now on worksheet 7.2, these are not calculator problems. Okay, all of these are, we're going to have to work them out. Okay, now some of these are going to be a little long, so you may want to do it on the back or on a separate sheet of paper, but you're going to have to show some steps. Okay, so on worksheet 7.2, we're going to be solving exponential equations. So here are the rules when you're solving exponential equations. We want to rewrite both sides using the same base. Okay, excuse me. So first of all, I want to look, and I always start off with my smallest number. So my smallest number is 4. Is there any way I can write 64 as 4 to some power? So 4 times 4 is 16. 16 times 4 is 64, right? So do you see that 64 is actually 4 to the third power? So I want to rewrite both sides using 4 as my base. So I don't do anything to my left side. I already said I can rewrite 64 as 4 to the third power. But since I have this x minus 3, I need to go ahead and say, well, that's 3 times whatever was already there. Okay? Now, after you rewrite and you have the same base, once you have the same base to solve, you can drop your bases and you're just going to set your exponents equal to each other. So then it becomes an Algebra 1 problem. So now I have x plus 35 equals 3x minus 9 because I had to distribute my 3. Now I'm solving for x. I'm going to subtract 3x. So I get negative 2x plus 35 equals negative 9. Subtract 35. Negative 2x equals, what is that, negative 44? So x equals 22. Okay, so if I plug 22 in and checked it, they're going to equal each other. Pretty much. Okay, that was number 1. Let's go ahead and do number 2 because I want to show you what you're going to do when you have a fraction. Okay, first of all, I need to rewrite both of these using the same base. What do you think I'm going to use as my base? Okay, well, here's the deal. When I have a fraction, I'm gonna use the same base that I normally would, but when I write my exponent, it's going to be negative. Because look, 8 squared is 64, right? But what is 8 to the negative 2? Well, anytime I have a negative exponent, what did we do? We had to move it. So 8 to the negative 2 is really 1 over 64. Do you see that? So anytime you see a fraction, you automatically know that when I rewrite it, my exponent is going to be a negative exponent. So I can rewrite 1 over 64 as 8 to the negative 2, but then I still had that 0.5x minus 3. We can't have negative exponents in our answer, but we can use negative exponents to help us get our answer. So now that I have the same base, what am I going to do to my exponents? I'm going to set them equal to each other. So I have negative 2 times 0.5x minus 3 equals 9x minus 2. Okay, so negative 2 times 0.5, what is that going to be? Negative 2 times a half. It's negative 1, right? Or negative x plus 6 equals 9x minus 2. When I solve for x, I'm going to subtract 9x minus 10x plus 6 equals negative 2. Subtract 6, and I get negative 10x equals negative 8. So when I divide by 10, I get 8 over 10 You can either write that as a decimal or that is 4/5. Okay, let's do one more from that top section. Let's do number 5. So on number 5, what number do you think I should use as my base? Huh? 0.5? What number should I use as my base? So I know I have a fraction. If I have a fraction, that's going to give me a big hint. Okay? 1/2. Do you see that 2 to the negative 1? What is 2 to the negative 1? 1 over 2? 1/2? Okay, can I write 16 as 2 to some power? 2 times 2 is 4, 4 times 2 is 8, 8 times 2. So 2 to the 4th is 16. So I'm going to rewrite each one of these. 2 to the negative 1 equals, and this negative 1, I still had that x minus 3 there, equals 2 to the 4th, but then I still had my 3x plus 1 there. So I have the same bases. That means now I can set my exponents equal to each other. So now I'm going to solve. I have negative x plus 3 equals 12x plus 4. I'm going to subtract 12x. Negative 13x plus 3 equals 4. Subtract 3 and I get negative 13x equals 1. So x equals negative 1 over 13. Okay, so that's how you're going to do 1 through 6 at the top. For right now, I want you to skip problems 7 through 12 because I'm going to have to show you those, and we'll probably just show you those tomorrow. But I want you to go down to 13 through 18. 13 through 18, we're going to do the exact same way, but we have inequalities instead of equal signs. So let's do number 13 first. I see a fraction. What number do you think I need to use as my base? 20. Okay, so I can rewrite 400 as 20 to what power? Squared. Because I know I can rewrite both of these as 20 to some power. 20 squared is 400, and 20 to the negative 1 is 1 over 20. So I have negative 1 times the quantity 7x plus 8. Now I have the same base. So now I can set my exponents equal to each other, but instead of equal, it's greater than. So I have 2 is greater than negative 1 times the quantity 7x plus 8. Now I'm going to solve just like I would normally. 2 is greater than negative 7x minus 8. Add 8 to both sides. And I have 10 is greater than negative 7x. Divide by negative 7. Now when I divide by negative, what do I do to my inequality? I'm going to switch it. So I have negative 10 sevenths is less than x. But then aren't we used to seeing our variable on the left-hand side? So I'm just going to switch this whole thing around. You can leave it like that, and I wouldn't count it wrong. But normally we would see it as x is greater than negative 10 sevenths. Yes. Yes. Okay, let's do one more. And then I'll have to show you 7 through 12 tomorrow, and you'll have the rest of the hour to work on this. Let's pick one from 13 through 18. Which one do you want to work together? Or we don't have to work. Number 18. Yes. I could write it like this, but normally we like the variable on the left-hand side, so that's why I switched it around. Okay, let's do number 18. 18. What do you think I'm going to use as my base? These are pretty big numbers. If you don't know, okay, I'm going to start with my lowest number, which would be 128. And I'm going to see, well, would 128 to some power give me 1,024? So if I square that, am I going to get 1,024? Does anyone know? I don't. 1,024. Whoops, let me get rid of this. It's going to be way bigger. Squared. Whoops. 1,024 squared. It's way too big. Okay, so I know I can't use 128. Any other suggestions? Two, that's going to be pretty small. What about, let's try 4. I don't know, just looking at it. So if I do 4, so 4 times 4 times 4 times 4, 256. What was I needing? 128, so that's not going to work. So is it 16? So let's try it. 16 times 16 is 256, so that's too much. But yeah, so that won't work. So I guess we'll have to use 2. 2 times 2 times 2, that's 8, times 2, times 2, uh-huh, times 2, times 2, 128. So my base is going to be 2. No. Take the square root. Mm-mm. So 2 raised to the 6th, check, is it 2 to the 6th or 2 to the 7th? To the 7th. All right, so that's 2 to the 7th, and that's x plus 3, is less than, now I can use 2 as my base, but it's going to be to the negative something, right? Well, if 2 to the 7th is 128, okay, so times 2 would be to the 8th power, times 2 would be to the 9th, times 2 would be to the 10th. So it's going to be 2 to the 10th. So it's going to be 2 to the negative 10 times 2x. So now I have the same base. Now I can set my exponents equal to, but instead of equal, it's less than. Whoops. So that's going to be negative 10 times 2x. So once we have the same exponents, we can drop our bases and set our exponents equal to each other. Okay, because we're solving for x. So now I have 7x plus 21 is less than negative 20x. Subtract 7x. 21 is less than negative 27x. I have to divide by a negative, which means I have to switch my inequality around. And 21 over negative 27, that will simplify each one of those by what, 3? So that's what, 7 over negative 9? I can leave it like that, or I can say x is less than negative 7/9. This is the preferred answer. Okay, so you know how to do all of the problems on this worksheet except 7 through 12. Okay, 7 through 12, I'm going to show you at the very beginning of the hour tomorrow. Then you'll have the hour to finish this, and then you'll have the next video to watch. Okay?